we discuss set. So what is the definition of set? A definition of the set is a set is well-defined collection of objects. So first, what is the meaning of the well-defined? So we consider the example. Well-defined, that means set, and not well-defined, that means not a set. So a set of numbers from 1 to 10. Set of number 1 to 10, we know that this is the well-defined because 1 to 10, 1 to 10, so we write 1, 2, 3 up to 10. This is the perfect well-defined set. Okay. Now, a pack of cards, we know that. A team of players, this is again, we define number of players of a team. So all three example, it says that this is the well-defined. Now another side, what is the not well-defined? That means not a set. What is the difference between the well-defined and not well-defined? Suppose we consider the example a collection of tall students in your school. So this word is not a well-defined, tall student. So we can't consider the student, this student is a tall, yeah, this student is a short, because he are not exactly the height. Suppose 150 height is the taller and 160 height is again the taller and 140 height is the shorter. Here not defined. So this is not a well-defined set. Now another example, collection of honest person in your colony. So we can't say this person is honest, this person is not honest. So again, this honest word is not a perfect well-defined. Now next example, collection of intelligent student in your school. So again, this word is not a well-defined. So all types of the example which is not a well-defined, and therefore this is not a set. But in the left side here, we define the sets, a set of number from 1 to 10, a pack of cards, a team of players. There are many examples which is a well-defined. Okay, so basically set, that means well-defined collection of object. Well-defined collection of object. This is a set. Now, what is the history of the set? So, the theory of the set, of the set was developed by the German mathematician Georg Cantor. So this mathematician, which is developed a first theory of the set, and therefore is known as the father of the set theory. So nowadays, the set theory has become basic to the most of the concept in the mathematics. If we know the set theory, then easily we understand the concept of the mathematics. So a set is usually denoted by the capital letters of the English alphabet, and its element is the small letters. So if we write the set and we define the set, so we always write in the capital letters, and its element we write in the small letters. So now some standard notation to represent a set. First, n is the set of the natural number. N is the set of the natural number, and in this set the number is defined 1, 2, 3, 4 up to and so on, infinity. Okay. So suppose, as for example, we draw the straight line. So this natural number is starting from the 1, then 2, then 3 up to and so on. So this is the natural number set, and natural number set is defined with the capital N. Now next, the set of whole number. So now in a natural number, we add 0. We add 0, then the set is said to be a whole number. So in the whole number, the first value is 0, then 1 up to and so on. Now the next set is the integer set. So in the integer set, we consider the negative value, 0, and the positive value. That means up to infinity, negative also -4, -3, -2, -1, 0, then 1, 2, 3, 4 up to and so on. Okay, so we draw then in the integer set, this value is a 0. In the left side, the negative value. So here we write -1, here we write -2, okay, up to and so on. So left side infinitive, and right side here we write 1, then 2, up to and so on. So this set is an integer set. Okay, only 1, 2, 3 up to and so on, then natural number. We add 0, then the whole number. Whole number is denoted by capital W. Natural number denoted by capital N. And the integer set is denoted by capital Z. In the capital Z, the element is a negative, 0, and the positive. Now next is a rational number. The set of the rational number. The set of the rational number is denoted by capital Q. And the definition of the rational number is a P by Q such that Q not equal to 0 and P and Q belongs to Z. Okay, a number which is always defined with the P by Q, where Q, that means the denominator not equal to 0, but we can take P and Q belongs to Z. But Q we can't consider as a 0. Okay, because we consider the 0, then the value is infinity. So a set which is defined P by Q, where Q not equal to 0 and both value belongs to Z. That means suppose we write 1 by 2 rational number, 3 by 4 rational number. P is equal to, we consider -1, -2, Q is considered 3, 4 up to and so on. Okay, so all are the rational number. Now next is a irrational number. Irrational number is denoted with I, which are not a rational number. The decimal expansion of a irrational number is neither terminating or nor recurring. Okay, so a rational, what is the difference between the rational number and irrational number? So we define this type of the form, then we can say the set is a rational number. Okay, and suppose a number which is not a rational number, then we can say this is the irrational number. Okay, and another definition of the irrational number. So the decimal expansion of the irrational number is neither terminating. That means suppose if we write 1.1.2, 3, 4, 5, 6 up to and so on. So this is not terminating. Okay, not end. So this value is a irrational value. But suppose if we write 1 by 2. So 1 by 2 is a 0.5 and 0.5 is the exact. This is the fixed value 0.5. After 5 there are no decimal. So this value is a fixed value. So this is a rational number. So what is the difference between rational and irrational? Rational, that means the P by Q, and the decimal expansion is a terminating. Okay, that means the fix. So this is the rational number, and otherwise suppose not ending, so this is the irrational number. Now the biggest set is the real number, and the real number we denoted capital R. So a real number is a number that can be found on the number line. That means suppose if we write this straight line, so in a natural number only we write 1, then 2, then 3. Okay, not between them number is involved in a natural number. But okay, so this is the natural number. Now we add 0, then whole number. But again, the between 0 and 1, which is not involved in the whole number, then we write the negative, so -1, then -2, then -3, up to and so on. So this is the integer. Again, between them, which is not involved in the integer, then rational number. So 0 and 1. 0 and 1, there are infinitely rational number and irrational number between 0 and 1. But all number is not in a rational, not in a irrational. But we consider the set of real number. So the set of real number, that means in a line we consider the any value. Suppose this value, this value, this value, that means whole things, rational as well as the irrational number, both are classified in a real number. Okay, so real number is the biggest set which is involved a rational as well as the irrational number. Okay, so this is the set of the real number. So a real number is a number that can be found on the number line. Suppose we consider the any point 0.001, 0.000001. So all points are inside in a real number. So real number are mainly classified into the rational and irrational number. So we add both rational and irrational number, then we define the set of the real number. Now, how to represent of a set? So earlier we discussed a set is denoted with the capital A and its element is denoted in a small letters. So now, first, the representation of a set, the first method is the roster method. A roster method, that means the tabular form. So what is the meaning of the tabular form? So in this method, a set is represented by listening all its elements and separating them by comma and enclosing them in a curly bracket. As for example, if capital V be the set of vowels of English alphabet, so it can be written in a roster form is capital V is a curly bracket A, comma E, comma I, comma O, comma U, bracket close. So this is the roster form, yeah, tabular form. Now consider another example. If a capital A be the set of natural numbers less than 7, so we write the capital A in a curly bracket 1, 2, 3, 4, 5, 6. Okay, so the first representation of a set is a roster method or the tabular form. So in this method, a set is represented by listening all its elements, separating them by the comma and enclosing them in a curly bracket. As for example, suppose we consider the set of vowels of English alphabets. So capital V, which is denoted by the set, in the curly bracket, the small letter is elements. So A, comma E, comma I, comma O, comma U, and the same 1 to 6. Now the another form is a set builder form. So what is the meaning of the set builder form? So in this form, elements of a set are not listed, but these are represented by some common property. So we can't write in the we can't write in the comma or listed the element, that means the tabular form, and we use the some common property for a set builder form of the representation of a set. As for example, suppose we consider the same example, let capital V be the set of vowels of English alphabet, then the capital V can be written in the set builder form as capital V is equal to the curly bracket X such that X is a vowel of English alphabet. So this is the set builder form. So how to write? Suppose we consider the sum x and the x value is the vowel of a alphabet. Now next, let capital A be the set of natural number less than 7. So we write this example in the set builder form. So the capital A in a curly bracket x such that the x belongs to a natural number. So x belongs to n and x is the less than 7. So here we write less than 7. So in mathematically we write less than 7. So x less than 7. So this is the set builder form. So again, there are two forms of the representation of a set. One is the roster method, that means the tabular form, and the another is the set builder form. Thank you. We end lecture 1. Now, in the next lecture, we continue lecture 1.